Okay, today's lecture is a continuation of the topics that we discussed last week. So we can think about them as together two lectures about emergence, reduction, and the mental physical relations. So I will just get control of my mouse, and I just remind you briefly about what we discussed last time. We discussed the relation between emergence and reduction, at least the way I presented it. Reduction and emergence are two aspects of the same property, the property of a macro level phenomena, theories in relation to the lower level description of the same system. On one hand side, high level can be reduced, at least in principle, to low level. On the other hand side, and sometimes they are emergent properties of the low level. Okay, so emergence and reduction, and also we discussed a little bit the issue of multiple realizability and the universality aspect of that. And the last part of last week's lecture was describing how, in physics at least, we view the fact that the same macro property, the same macro properties can be shared not only by many microstates of one system, but also by very different systems in terms of the microscopic structure. Nevertheless, we can understand why all these classes of different systems exhibit the same macro properties. And I mentioned briefly renormalization group in physics as a mathematical mechanism to actually identify those different universality classes. Okay, I want to we didn't discuss, we didn't have time to discuss another aspect, potential aspect, or another question about emergence, and this is the issue of causation. Are emergent phenomena in some sense autonomous or have some degree of autonomy in terms of the causal power? So this goes under emergent causation and downward causation. I'll explain what they mean, and I'll close this chapter by my suggestion for what I call microphysical closure principle. All this list here will complete our discussion about reduction and emergence in physical systems, so in systems which are naturally belong to physics, chemistry, biology, and so on. Then lecture 11, which will be the second part of lecture today, will be devoted to the question about the mental, physical, or mind-brain relation. And namely, the question would be, is what we have concluded about the macro versus micro relation in physics, or maybe in other sciences, is it good analogy to mental to physical relation or reduction? That will be the second part of the lecture today. Okay, so I'll skip all this, and I'll start with with the question of causation. Okay, so as I described in the introduction to last week's lecture, part of the excitement about emergence, about the concept of emergence, is that it gives some hope that one can adopt an intermediate position between kind of brutal reducibility or reduction. Those reductionists, they are really materialists, they're really bad guys. Everything is particles and quantas and so on. They don't see the complexity of the world around us. On another view, those dualists, which dreamers, the dream about things which are not really don't really exist, ghosts, spirits, and so on. So there is emergence sometimes is adopted as kind of intermediate position. Sometimes it's called the non-reductionist physicalist or something like that. Okay. So far, emergence was benign the way I described it. Okay, so there is novelty, there is some surprising phenomena, there is symmetry breaking, all these good things about it. But can we take it further? And further, the way some philosophers and some scientists want to take it further by saying that macro emergent theories is not only kind of a useful description of what happens in a microscopic, which is relevant to the macro, but they have some sort of independence, and specifically in terms of the causal forces. So one can say that if I, for instance, change the temperature of a physical system, a thermodynamic system, I don't know, container of gas, then I'll see change in energy or in pressure or whatever. This is a causal description. If you do this to the macros directly in terms of macroscopic variables, if I change a macroscopic variable like temperature, I will see a result in a change in the macro properties. So it makes sense to think about the macroscopic theories, at least some of them, as describing macro-causal relations. Okay, so how does one view emergent phenomena and theories or laws which are macro or emergent? Do they acquire some autonomy in their causal power? This is a big issue and confusing issue, but it's very close to the heart of many emergentists, because that's the criterion for them to distinguish between a weak sense of emergence, that, okay, it's good to have macroscopic description, it's nice, and a more kind of metaphysical, strong sense of emergence in saying, well, there is something new that's occurring, and there are new laws operating on the macro level. So Roger Sperry was one of the influential emergentists in the 70s and 80s and last century. In his Nobel Prize lecture, I'm giving you a quote, "The events of inner experience," he's talking about mental to physical, but for now, I'm not making a distinction. Let's think about it as macro versus micro, okay? As emergent properties of the brain processes, because they themselves explanatory causal construct in their own right, interacting at their own level with their own laws and dynamics. So there is some realm of a macro, in this case it's mental, but a macro, where there are really genuine own causal rules. Macro one if you do this to macro one, you will generate a change in macro two, and so on and so forth. This is also was even earlier in the beginning of the 19th century by the British emergentists, Samuel Alexander and Broad and others. They expressed the same sentiment. Famously, Samuel Alexander, I like the quotation. He says, "Well, you may not like it. You may think, okay, well, how come those macro high-level causal forces, where they arise from?" And he says, okay, but maybe this should be accepted with the natural piety of the investigator. Natural piety. I like it. It admits no explanation. It's a brute force. It's a brute fact about our world. There is a micro realm and there is a macro realm. And both of them have their own causal laws, causal mechanisms, micro mechanisms and macro mechanisms. And they bring examples, not here, but examples from physical systems. Maybe we'll see them later on. The famous, one of the famous philosophers, and Fodor, says if it's not literally true that my wanting is causally responsible for my reaching, and my itching is causally responsible for my scratching, and my believing is causally responsible for my saying, if none of this is literally true, in other words, if the mental doesn't really have a causal role, then practically everything I believe about anything is false, and it's the end of the world. And other philosophers of science and mind, like Popper, says it's the end of everything. If this is not the case, if mental doesn't have autonomous causal forces, then it's the end of the world. What are we talking about? End of the world. Okay. So the question is, how can we make sense of this idea of emergent causation, that the macro or the more complex high-level systems have causal powers? How can we make sense with about that, and at the same time commit ourselves to what I call physicalism, that there is no other things than at the end all the macro systems are composed of micro constituents, and none of these people disagree about that. Okay, so emergent causation is the thesis that emergent systems acquire causal forces independent of the microcausal forces. That's a statement. Okay, so the problem, okay, the very big problem is that one thing is to say, if I go back to here, one thing is to say, like in this statement, that there is a certain causal relation between macro states, which are described by the macroscopic laws, or even mental, that if a mental state occurs of type 1, then another mental state of type 2 will occur. That's maybe fine. But the problem of interaction is, of course, the obvious problem, because everybody understands that if a macro state changes, then the microscopic constituents also change their configuration. Otherwise, supervenience is lost, right? You cannot have a change in the macro level, or even in the mental state. M1 cannot go to M2 if we believe supervenience, that an identical physical system on the micro level will have identical macro properties or mental properties or whatever. Okay, so that's the problem. How do make consistent statements about emergent causation and supervenience? So that's basically the problem. So one can say, well, high level, H is for high and L is for low. High level causal forces work only at the high level. But as I said, this is a problem. There is no, one has to say something about low level. So another potential answer is the high causal forces work on the low level. Okay, so kind of just conceptually, I'm trying to clarify what possibly emergent causation means. Okay, we'll see it in a moment. And the problem with this idea of emergent causation, in each of these versions, option 1 and option 2, answer 1, answer 2, the problem is, or one of the big problems, was elucidated, articulated by a philosopher that I highly admire. He made a big influence on my thinking about these issues, Jaegwon Kim. And he articulated the problem in a series of influential papers and books, and called them causal exclusion problem. So let me explain what the problem is. It's kind of obvious, but until you articulate exactly what it means, it's remain fuzzy. So here's the problem. If you assume supervenience, so let's say there is M1, there is a macro law that says M M is mental, P is physical, but for us, M is high and P is low. Okay, so imagine there is a macro causal force that induces or is in charge of changing M1 to M2. Okay, macro 1 to macro 2, or mental 1 to mental 2. However, because we believe in supervenience, okay, so P1, so M1 must be realized by some physical state P1, and the same physical state cannot have two different macro states, two different low, right? So the micro states, the macro M2 must be realized by a micro P2, or mental to physical, whatever. Okay. So the problem is if we make this statement, then there is a problem, because at the same time I can say, although there is a macro level law that says M1 goes to M2 causally, but at the same time it must be that there is a change, a law that change whenever there is P1, it goes to P2. Otherwise, what is the miracle here, right? So then we have two possible explanation for M2. One explanation is the macro explanation, M1 goes to M2. But another explanation is P1 goes to P2, a micro causal force, which then through supervenience give rise to M2. So we have the problem of two causal explanations competing for the phenomenon of occurrence of M2, or for the change from M1 to M2. And the principle of causal exclusion says it doesn't make sense. If already we can understand M2 through the change from P1 to P2, what do we need the other macro causal law? It doesn't do any work. Causal exclusion says you cannot explain the same event causally by saying, either A caused B or C caused B. If A is sufficient to generate B and A happened, it doesn't make sense to say at the same time, no, B caused A, right? Or the same time, right? So B and B prime cannot, both of them, be responsible for inducing the same change or for giving rise to the same state A. There was a question here.
Yes, I have a question.
Yes.
Maybe a bit besides the point, but couldn't it be also that M2, like P1 causes M1, M1 causes M2, but then it's M2 that causes P2. So
okay, I'll present something similar to that, to what you suggest. I think it will be similar. So this is one scenario, and this I think might be similar to what you said. And again, if there is time, if there is a time delay, then what I'm suggesting here makes more sense. That M1 generated causally M2 not by somehow mysteriously operating on M2, but through changing the microstate. So through causing the occurring of P2. Okay. So this is the possibility, but it also suffers from the same problem, because now P2 has two possible causal explanations. One that P1 generated P2, another one that M1 generated P2. So it's a different scenario, but the problem is the same. So I'll come to alternatives, yet a third scenario. I'll come to that, but for now, we see the problem that if we believe that the macro is a macro M1 to M2 by supervenience is paralleled by a change, a law that changes P1 to P2 then these two, one of them is enough to explain what's going on. All right, so that's so either this or that. That's the principle of causal exclusion. No single event can have more than one sufficient cause occurring at any given time. Okay, and again, mental to physical for us is just macro to and there is a so let's summarize this. What is the problem of emergent causation? The way I summarize it is the following: emergent causal relations, you cannot deny that laws of macro physics is in terms of make causal prediction. Change this macro variable, then this will happen, and very often also in psychology, in cognitive scientists, if you are depressed, then you may do some you may have some other mental states as a consequence, and so on and so forth. However, they are indispensable in describing the macro world. So don't get rid of that. So I'm not in favor of being brutal reductionist and ignore the fact that macro science, macro world is described by macro causal relations. However, they're not independent causal relations. They emerge. They are in principle derivable from the causal forces at the micro level. Okay, so they are not two independent causal explanations. In principle, the macro law reflects the micro properties, but this is in principle, and it's not something that will help us in understanding the world around us, because it's it's opaque. It's in principle, it's a commitment in principle that this is what happens, and very often we are able to show this, and very often we are not. So, but that's what we believe is the story. All right. So I in that sense, I'm not suggesting to hold to a very strong metaphysical notion of causal emergent causation. Okay, good. There's another version of that down there, which is the version of overdetermination. It's the same idea that you cannot overdetermine the causal, the appearance of event by two causal stories. So that's fine. Now there is another possibility, and this may be what Gili had in mind. I'm not sure. And this is the following. The fact is that M1 gave rise to M2 by inducing a change in the microstate from P1 to P2. However, this change is not compatible with the microcausal relation from P1 to P2. In other words, if we just left to the microscopic theory, we will not predict M1 goes to M2. Okay? So that's, you remember here, in both cases, we assume that the M1 to M2 change is compatible to P1 to P2 change. And then we said, then one of them is redundant. And since we like physics, why not? Microphysics is nice. Anyway, one of them is redundant. Here, no, it's not. Because at the micro level, there are some rules, but in a macroscopic context, the change in the micro constituents are really different. The macro level can affect the behavior of the micro constituents. Okay, so that's a very strong statement. It's called downward causation. Okay, so emergent causation says, well, there is some independent rules at the macro level without really explaining what's going on. Is it redundant? Or downward causation is a very strong and clear statement. The macro level are not only autonomous, but they are actually capable, licensed to change the micro rules. All right. So, and again, if you look at quotations, There are many, I won't go over them. Look at the last example that Sperry, the last quotation from Roger Sperry. Again, the previous one that I brought was about experience, mental, subjective. Here it brings a simple example. Imagine you have a wheel that rolling down a slope, mechanical system. So the wheel is a solid object with certain geometry causes it to roll down in a certain fashion. But we can describe by macroscopic mechanics. But what happened to the quanta? Well, they are forced to roll also together with the wheel. Okay, so the macro is imposing the motion, is imposing on the individual microscopic quantities. They don't know. If you ask an atom inside the wheel, it won't know that there is a wheel, that there is certain geometry. It's just an electron, an atom. Okay, so you see that the macro can change can influence the motion of the micro, and there are many examples like that all over the place, all over the literature. And again, what I want to emphasize that the examples of downward causation that you find in the literature, in philosophy, and sometimes also in physics or in other sciences, scientists expressed by scientists, they all adhere to the idea that the downward causation operates not only in mental to physical, but in the physical world. That the macroscopic world has brought about acquired forces that can influence, can change what would be otherwise the motion of the microscopic constituents. Downward causation.
Haim.
Yeah.
But in the case of the wheel, doesn't gravity act on each atom separately?
Yes, but I think what Roger Sperry and others have in mind is that the geometry, the boundary condition, the specific pattern of the rolling of the wheel is not something that you can describe on the single atom. It is true that gravity acts on a single atom, but the pattern of rolling down is fixed by the macroscopic geometry. That's the argument.
But doesn't it only mean that it's complex to describe the global motion by treating the single atoms, but possible if you take all those boundary conditions and interactions and forces into account, it will be a very complex description, but in principle it's possible.
I agree with you, but I just want to say that those that are downward causationalists, they don't think it is just a matter of, a coin size and not only coin size, but only practical way of describing the macroscopic properties, but they believe that there is that there are some aspect of the macro system that is not captured by the micro relations. I'm going to criticize that, but I'm going to I just want to clarify the position. This is the position. Sometimes it's
probably when you move to cognition, it gets more difficult.
We'll come to it, but sometimes it's called, the whole is more than the sum of its parts. That there is a holistic aspect to a complex system that you cannot, in principle, capture by just describing the individual forces and the interaction. I'm not saying it's right or wrong. I'm just saying this is the position. Okay, and of course you already hinted about the problem. So if we try to delineate this position, there are several options. And when I say options, is options that you find in the literature when people try to elucidate what does it mean. Option one is that natural piety, like Samuel said. Right? Okay, you don't like it, fine, but that's a brute fact of the world. We cannot explain it. It's maybe against what we understand about the microscopic physics and whatever, but there is a holistic aspect to our world around us, and that's what we see. And mental, physical, macro, micro, this is the way the world operates. Now, of course, we don't like it because, again, the issue of supervenience is now basically violated, and to some sense, and it's basically anti-physicalist in a way that I'll describe later on. But that's one version. There is another version, which, again, even physicists sometimes say self-organization, boundary condition, context. I mean, sometimes even physicists talk about this, that the macro, the complex system, has a context which is set by the macro level, or even goals was set by the macro level, or boundary conditions, and so on and so forth, geometry. And but I agree with Nimrod that here the problem is that all these boundary conditions and context and goals, all of them operate, or at least we can explain their operation as the sum total of interaction at the microscopic level. For instance, between gas molecules and the molecules at the walls of the container, and so on and so forth. So, so there is no mystery as to how boundary conditions affect the microscopic systems. So this is the problem with this notion. And finally,
Haim, sorry,
yes.
Can you please explain that again, because I didn't follow.
Yeah, so it is true that we often describe the properties of a macroscopic system, not only saying, well, there is gravity, there is electrostatic, and so on, but we also say there is boundary condition. Okay, for instance, in electromagnetism, when we describe the electromagnetic fields, we said, yes, but you have to assume some boundary conditions to have a unique solution. Or in thermodynamics, obviously, we have a gas, but the gas, the thermodynamic state will depend on the number of particles in a certain volume, enclosed in a certain volume. So that's kind of a boundary condition. But if you ask how the boundary conditions affect the motion of individual molecules, I mean, individual molecules doesn't know about macroscopic boundaries. The answer is very simple in principle. Molecules in the gas hit another molecule in the wall, and because the solid, unlike gas, is more dense, or the interactions are stronger, the interaction causes the gas molecule to bounce back into, rather than to penetrate through the wall. So it's not, it is to say boundary conditions is a coincidence way of describing the effect of interaction between individual microscopic constituents with another microscopic constituent, so set, in this case, the walls of the gas. And similarly, yes, go ahead.
So there is nothing new. This is what you're trying to say.
Yeah, there is nothing new in principle. There is no new principle saying macroscopic boundary condition is a new principle, which is not accounted for by the microscopic physics. And the same, the wheel rolling down, as already I answered. Indeed, individual molecules are individual molecules. They have gravity, they have interaction between other molecules, but they are confined to the geometry for the similar reasons. There is a tension, there is a different interaction. They cannot escape that from the boundaries by their interatomic interactions, nothing else. Okay, so in that sense, Yeah, so again, self-organization is the same phenomena. Self-organization is a beautiful and important phenomena, but it's not something that we cannot explain its causal mechanism by the microscopic world. And again, I want to emphasize what I emphasized last week. When I say microscopic world, it's not individual atoms. It's not that I'm saying the microscopic world is just a collection of atoms we don't interact with each other. No, it's everything. It is with the atoms in the wall and the atoms in between and all their interactions and so on. So it's not between a macro system and individual micro element, between a macro system description in terms of a microscopic description of the very same system, macroscopic system. Okay.
Isn't entropy a good example for something that you can describe mostly or maybe only in the macro states and not in the micro? Because every microsystem can reduce entropy, or like the time error is not well defined, and only when you go to the macro description you have this kind of
but the answer is again the same. It is true that entropy and the violation of the error of time, of time reversal symmetry, cannot be observed by a small aggregates of atoms or molecules of the same system that we are looking at. It is true. But on the other hand, when you have a macroscopic system, okay, the emergence of error of time or the entropy and so on are explainable in terms of the behavior of the macroscopic system under the microscopic rules. And that's what we discussed at length when we discussed a microscopic mechanical origin of the violation of error of time. So I'm not saying that the macroscopic system doesn't have phenomena, properties that are new. I'm not saying that. I'm very fond of emergence. But I'm saying that those new phenomena, those novelties, those patterns, the symmetry breaking, all these beautiful things, violation of error of time, all these are explainable in terms of causal mechanisms that operate at the microscopic level. That's all what I'm saying. Okay, I'm not against emergence, but against the idea that emergent systems somehow have new physics operating on the microscopic level, not on the macro. In other words, for instance, if there is a breakdown of error of time, somehow now single atoms behave differently than Newtonian mechanics. When we explain entropy and the violation of error of time, our explanation says that all atoms, all molecules in the system, their motion is still governed by the same Newtonian mechanics as we know, except that this Newtonian mechanics at that scale give rise to this beautiful phenomena, new phenomena. Okay.
Okay, thank you.
Dr. Sompolinsky, can I ask a question?
Haim,
sorry, this is Joel.
Yeah.
Can I ask a question?
Yeah.
But isn't it kind of at least philosophically a question in terms of where the micro stops? Because we can go micro to atoms, to molecules, to atoms, to subatomic particles, to fields that make up the subatomic particles, and other mechanics that might be causal that we haven't discovered, and we don't even know where that ends yet.
It is true. It is true. And an echo of your sentiment, if I can say, is given in some of the writings of a well-known philosopher, contemporary philosopher, Ned Block from NYU. And he called it the problem of causal drainage. He says, well, you're reductionist and you're stupid, right? Because you say that, you explain the mental, physical neurons by ions, ions, by electrons and nuclei and so on, then by quanta, by particles, and then particles by fields, and fields by strings. And the problem is that who said that there is an end to this story? Who said that the world has a final microscopic scale that stops there? Nobody really guarantees this. Imagine that strings are even composed of, you know, some other entities, and these entities or other entities. So nothing is in charge of nothing, because imagine that the hierarchy of going down and down the scales really doesn't stop. That there is always new physics at the more microscopic level. Then he says, you lost any causal explanation. You cannot say anything about it. What you cannot say strings are the causal explanations, because they are not, because there is something. It's interesting Talmudic, I would say, twist. I am not very impressed about it. I'll tell you why. Because I don't think, if this is indeed the case, that there is no end to this. Strings go to something else, and something else goes to even smaller and smaller and smaller and smaller. Okay, so who said it has to stop? Who said our causal explanation has to have a bottom line? Aristotle said, you know, there is a prime mover. You cannot go, you know, endlessly in the past. You have to start from somewhere, and this is God, prime mover. I'm not so convinced that this is a very okay. So indeed, as you said, there will be fields, and there will be quarks, and there will be strings, and there will be all kinds of, maybe it will never end. Okay, so that's the world. I'll accept it with natural piety. Okay, causal, there is no guarantee that there will be ultimate level from which we explain everything. It may not be. Okay, so our causal explanation will be, you know, down to a certain level. That's on kind of metaphysical ground. On the practical ground, you're absolutely right. So thermodynamics, statistical mechanics, for instance, explain largely how thermodynamics emerged from statistical mechanics, which is at the level of atoms, you can say, you know, spins, molecules, and so on. Now, quantum mechanics, statistical quantum mechanics, go down further to explain kind of how quantum phenomena occurs, but nobody will explain, nobody is interested or thinks it's practical in any sense to explain condensed matter in terms of quarks or in terms of strings. Okay, but we believe it's just a matter of degree. In other words, it doesn't make sense, but there is no, in principle, you know, there is a degree for which we can gain by making the connections, and then the degree by which we don't gain by making those connections. And I already said about it, and we'll come back to it later on when we discuss computational cognitive neuroscience, that the degree depends on the dynamics. Everything is quanta, is quarks and electrons and so on. Everything is strings, maybe, or fields. But that's a structural statement. But we want to understand dynamic processes. So that sets the scale of space and time about which the battle rages, about which. So there are several levels who may interact, but not more than that. So I completely agree that there are levels too microscopic to actually worry about, but there is no metaphysical statements about that. In other words, the way a gas molecule moves around, in principle, you know, you can start from quantum field theory and talk about elementary particles, that make up the gas molecule, and then talk about the atomic physics, etc., etc. It's ridiculous. It's useless. But there is nothing which will stop us to do that. Okay.
Okay, thank you.
Okay. Option 3, I want to mention, and this is kind of more subtle. The argument is the following: every event that has, every micro event that has a causal source, a causal event at the microscopic level, okay, nothing can touch it. So the macro, there is no downward causation that will violate some microscopic, the outcome predicted by microscopic physics. However, we know that the world at the microscopic level is not deterministic. And if we believe quantum mechanics, then it means that there are events at the microscopic level which are not caused by anything from the perspective of the microscopic theory, right? An electron may be in one energy state, or maybe in another energy state. A spin may be up, may be down with some probabilities, which means that if the spin happens to be up, it's not, I cannot say it was caused by something else because it's random. So maybe there's a gap. There is a causal gap. In other words, because the microscopic physics is not deterministic, there is a gap. There are events that are not caused by the microscopic laws. And the downward causation fill in these gaps. They tell the electron to be in that state, not in that state, or the spin to be up versus down. It's again, it's a sentiment, or it is a position that has been adopted by several historically, but also contemporary philosophers and scientists. Now, what is the problem here? The problem is more subtle, but still we have to face it. We can say it is true. We should accept by a natural piety the fact that to best of our understanding of quantum mechanics, quantum physics in general, indeed, not every event is caused. There is randomness the way the God decided to construct our world. There is randomness. However, the randomness itself is part of the theory, is part of our fundamental laws regarding the microscopic level. Now, if you come and say there is something else that fill in the gap, then that something else is another, if you want, quantum force, which violates our known quantum mechanical laws. Okay, so it is illusion to say you fill in the gap. No, but the gap, the existence of the gap is itself predicted by the quantum mechanics. So this is why it's hard to see how this can be consistent with the best of our physics. Okay.
So the conclusion is that there is no clear mechanism by which downward causation could work?
Yes, let me say a few more words and I'll come to the conclusion. Okay. But before that, I want to ask the following question. Until now, what I said is the following. Okay, downward causation is a nice story, but it's not consistent with our understanding of physics. Quantum, not quantum, okay? It's not consistent with our established laws of physics, okay? But some people, because of that, come to the conclusion that downward causation is dualistic. Maybe, but I don't like this dualistic thing. My position is the following, and I want to kind of clarify my position, and I invite you to think the following. Let's forget about tags, gender discrimination. This is physics, this is not physics, this is mind, and this is body, this is brain. In terms, when we talk about causal things, okay, here's my position. Anything that is hypothesize to interact with the physical world is physics, is a physical force. I don't care how you want to call it. You want to call it spirit or soul. I don't care. This is just names. Who said gravity is a better name than soul? Soul is also a nice name. Why weak forces in nuclear physics is good name and spiritual force is bad name? It's also a good name. So I think the whole talk about non-physical versus physical, which kind of dominate part of the discussion, I think it's just not relevant. Anything that is claimed to affect causally physical components of a system is physics. Okay. And then the question is the following. Rather than saying non-physical acting on the physical, let's ask, why can't we accept that those macro level things are actually physical forces, whatever you want to call them, that are legitimately affecting the microscopic constituents. When I first gave this lecture at Hebrew University, one of the students asked me, why are you against the idea that the mental or the mind can affect electrons' movement? You don't like it because it's not in the textbooks. Okay, so let's rewrite the textbooks. We know that there is mental, we know that there is mind, we know that the macroscopic world around us behave in a very different way than the microscopic physics kind of predicts, okay? So can we think about, indeed, there are emergent macro forces, and this is the new physics. Okay, so it's against the textbooks. Shall we accept the causal role of macro laws on the micro component as part of the complete physical account of our world? Okay, so it's not the way we were taught. Okay, fine. Somebody that strongly believes that the mind, for instance, affects the brain and induces different mental properties, for instance, okay, will say, okay, so the mind is another physical force. I mean, good. It's not in the textbooks, but rewrite the textbook. So downward causation can be defended not by trying to wiggle room, context, boundary conditions, quantum mechanics, just by saying there is another macroscopic physics. There is another law. We know gravity, and we know nuclear forces, we know electrostatic. There is another. Mind is another force. What's wrong about that? Okay. I think this is a healthy way of thinking about all this issue. Why we are strongly, or some of us strongly, against the idea that there is holistic aspect to the system which affect the microscopic level of the same system. Okay, that's a question. Without excuses, quantum and so on. And here I think we're coming down to the core of the issue. And the core of the issue is that it's not only that it's not in our textbook of mechanics and physics or elementary physics. It against the foundation of how physics is built. Okay, so if somebody physicist comes and say, well, I discovered new force acting between certain particles. Okay, people will say, show the experiment, give, what is the theoretical reasons, what are the experimental findings. Some people say gravity has some modifications in order to explain. Okay, so people can come up with different microscopic forces, it's fine. But what I'm saying is to assume, to hypothesize a holistically generated force on the microscopic, acting on the microscopic constituents, it's not only that there is a lack of empirical evidence of something like that, it is more than that. It is against the best understanding how the physical world operates. And this is locality and invariance, okay? And I emphasized that at the beginning, the very beginning of the lecture, and I want to emphasize it again. Why I emphasized it there? Because whatever happens on the macroscopic level and in the way we understand it in terms of physics, it's always at the fundamental level is aggregate of sums of interaction between small number of particles, typically two particles, binary relations. In some field theory, maybe it is 4 fields interacting or 4 particles interacting, or something like that. It's a local. The aggregate behavior is a result of enormous sum and complex arrangement and so on, but forces which fundamental level act locally. And that's in somehow related also to the notion of invariance. Because of that, we strongly believe that gravitational forces that we measure on Earth are the same as gravitational forces on Mars or in another galaxy in the end of the world, okay? Because of the invariance in time and in space. So now somebody comes and say, well, the mind is a holistic aspect of the brain, and it acts on the neurons to generate action potentials. Namely, it acts on the ions, flowing inside and outside the neuron. And I'm saying that's fine, but this force, you have to be able to break it down and to explain how this force will translate into a local fundamental force. You will have to change the physics at fundamental level and at the lab, because fundamentally, if there is such a thing as downward causation, then we should be able to observe it. For instance, if we take a piece of membrane out of a neuron and inject and put it under potential, inject current, and so on and so forth. So, of course, you will object. You will say, no, this is holistic. But that's a problem. Holistic phenomena, as I explained earlier, holistic properties are fine, but they are come out of forces which are local, and invariant. They will act the same. The fundamental forces in my brain will act the same between the microscopic elements if I look at it in the lab. Okay, and this is basically the reason why experimental science is so successful. It's not because we like it and we assume, it is because it's imagine that you generate, you build a vaccine for COVID-19 by starting from studying the DNA, the RNA, the virus components in the dish, and then say, well, it will work in a human being. Okay, what's going on? Human being is a holistic thing and it's something else. No. And it's successful. So the enormous success of science over the last few hundred centuries is a very strong argument in favor of a fundamental feature of physics at the fundamental level. The invariance, that behavior of ions flowing or protein and so on in my brain will be the same if I enact the condition on the microscopic level in a dish, and because fundamentally interactions are local. So the fundamental interactions cannot arise just only 10 to the 11 neurons in a particular network configuration have this physical force. That's impossible. Not impossible, but that's unlikely given our understanding of physics. So what the bottom line is the following. It's not that I'm chauvinist, I'm against introducing or hypothesizing new physical laws or new physical forces. I'm hypothesizing that the physical forces that are suggested by downward causation or by holistic or dualistic aspect theory about the mind and the brain are suggesting kind of forces that are very foreign, very different to the type of forces that we are familiar with in physics at the fundamental level. So before I answer Liad, so here's my summary, which is to me is what has been written in the tablet that I would have taken down Mount Sinai. This is what I call principle of microclosure of physics, or the causal microclosure of physics. And this is it. All causes of events in a physical system can be accounted for by the local and universal forces acting upon the microscopic constituents of the system. Okay? This is, I believe that any scientist, and I believe all of you are scientists, must subscribe, must sign this petition. Okay? Otherwise, it doesn't make sense what he or she are doing. Okay? So it's, again, it's not that necessarily the list of forces that we know and familiar with is the only list of forces, but it is the type of physics, the nature of the way the physical world is built to the best of our understanding is what is sitting. So I'm very careful in my describing here the manifesto. I'm not saying that every physical event is caused, because as we said, quantum mechanics, to the best of our understanding, says that some physical events are not caused by anything, they're random. But what I'm saying is, if there is a causal force generating an event, if there is a causal force, this causal force has to be reduced to the microscopic causal forces that, whatever they are, they may be known and they may be unknown. I don't care. They may be unknown. I'm not saying those microscopic laws that we are familiar with. No, I'm just saying it has to be reduced to the microscopic level, at fundamental. So that's one thing. The other thing which I want to emphasize, I am not the first one that come up with the principle of closure, the physical closure. But I want you to compare it down there with Jaegwon Kim's closure principle, and the way he defined it, the causal closure of the physical domain. If a physical event has a cause at T, then it has a physical cause at T. That's the way he described it. And again, very influential closure principle. I have a problem with that, and I already said, because who said that mind is not a physical cause? I can call it physics. So I'm not happy with that. This is why I'm emphasizing the micro closure. So whatever new physics you want to generate, you have to get it down to the microscopic level, and then we can test it outside the macro context. Okay, then we can test if two electrons interact or repel each other with a new force which is called mind. Okay, so let's test it in the lab. Okay, this is why I'm emphasizing the micro physical closure. Okay.
Haim, can I ask a question?
This is the end of the first part. of my my lecture today, and it's open to discussion.
Yeah, so I have a question. You know, until the 50s, we used to think that nothing violates symmetry, and then they made an experiment and found that weak force violates symmetry. Why, we don't know, it just does. So there could be an exception to this law. I mean, maybe it's a rare exception, but I don't see why you would rule it out categorically.
No, I'm as I said, the best of our understanding. There are surprises, but again, I want to I skipped for the fear of redundancy and sake of time to list the reasons why I strongly believe to it. First of all the examples that people bring for this type of holistic influences, and they say, okay, you know, the scientific macroscopic properties like the wheels roll down on waters and patterns emerge and all this, we have a much better explanation without invoking, you know, physics. Okay, so that's one, and the second is that, as I said, over the history of science, modern science, all attempts to introduce such, I would say, holistic aspects like quantum holism, vitalism, and so on, failed. Okay, so that's an empirical fact. Okay, so I'm not. This is not a mathematical statement, but I think this is summarized the best of our understanding of the physical world. Okay, if someone wants to insist otherwise, it's fine. Okay, I'm not against it, but I'm just saying, I just want to emphasize it's not about having non-physical versus physical. It's about suggesting a physical force which acts fundamentally differently from the way we are familiar with other forces, with other physics. And as I said, if this is happening, then nothing that we do in neuroscience or in other complex systems in biology will make sense, because we take the system apart and study it in the dish. Okay, so, and it's enormously successful. So, but you can say it's successful to some degree, but there is some degree above which it's not. That's fine. I'm just explaining why I think this is, to violate this, you will have to have a very strong reason. So you showed an example of violation of symmetry. Okay, but you know, it wasn't taken lightly. It was a very strong experimental evidence and so on and so forth. And anyway, you're entitled. Everybody here is entitled to his own. I'm just saying this is what is at stakes. That's what I'm saying. Okay, more comments.
Can I ask a question, or are we taking a break, or?
We will be taking a break, but we can, if you want to ask questions before that.
Yeah, sure. So I was wondering, a few years back, I made the argument, and that I would present now, and I wonder if what you're saying actually fits into that or contradicts that. I'm not sure. So the argument was that in a way, physicalism is either a tautology or an empty concept, in the sense that whatever we find, so if we find via experimentation or any other method a phenomenon that contradicts the laws of physics, we will probably not call it non-physical, but rather change the laws of physics. So this is, for example, what happened with quantum mechanics. We found that a particle could be in the two places in the same time. That violated the laws of physics. So we didn't say, well, here is something that is not physical. We just said, here's a new physics. So I was wondering if what you're trying to suggest here is more or less the same. To say, okay, there is some evidence, or we think there might be some downward causation. It seems to violate the rules of physics. Let's not say that it's not physical. Let's just say that it's part of physics.
So this is what this was the first part of my argument. They're talking about physics and not physics, and sometimes physicalism says everything is physics, or the way Jaguar Kim says every physical cause, every cause of physical events is physical. I don't like this talk. I agree with you to the extent that the laws that you suggest or hypothesize affects the physical system, then it's physics. Here I agree, but now I'm saying that it's not simply a new physical law that is suggested in our context in down causation. It is a physical law which is not only new, but has a different nature, a foreign nature to all the other laws that we are familiar with, and the way the fundamental symmetries, invariances, and localities that are characterizing the non-physical laws. Okay, so it's not simply okay. So now I suggest, I get every week or so another email for somebody says, well, Einstein was wrong and this was wrong, and okay. I'm not saying it's easy to add another law, but I'm just saying that this is one thing. But here, it is a law which has fundamentally different nature, okay? Because it's a law which is purely contextual. You're saying only when you have so many neurons in this system, then the ions in this system behave like this. Okay, so I want to emphasize that aspect. That okay. Now, if somebody has a story by which the mind or something can be reduced to a new physics at the microscopic level, okay, then let's test it. Tell me what to measure and I'll test it. That's my point. Nobody came up with a story which says, then it's not down on causation anymore, right? It's not down on causation. You just hypothesize a new fundamental interaction or electricity or whatever. Okay, so tell me what it is, and then we can go to the lab and measure it in the lab and see if it is. Okay, this is the point.
I'm not sure I fully understand the essence with why the downward causation is not physical, or not going with what we know about physics, because like when you gave the example with the water bullet,
yeah, in a vortex, or okay.
Yeah, I mean, I was ready to buy it then, I mean, this is a physical system, and there is some laws that are macro, and they're working on the water molecules, but the laws that make this bullet are the macro ones. I mean, we didn't say all these three problems when we were talking about the water,
No, okay. The reason is the following. So indeed, it's a macroscopic phenomena, and we explain it by solving some macroscopic differential equations, and that's fine. But it is fully consistent and derivable from the interatomic interactions. It's not a new causal. It's not a new law of physics fundamentally. It is a phenomena, a macroscopic phenomena that emerges from the fundamental laws, which is interatomic interactions. That's what I'm saying.
Yeah, so, but the causation there is macroscopic. Like, I don't know, it's the
no.
No.
It's fine if you say it's causation macroscopic. Again, if it is at the same time also can be explained by causal relations in the microscopic level. So that's, you know, now we are fighting, you know, the exclusion principle. I don't care if you're saying you want to call it both a macroscopic causation and microscopic causation, which are fully compatible, then, you know, Kim may not like it because of causal exclusion, but it's fine. It's a philosophical question. I don't mind to say that it's both macroscopic and microscopic. It's fine. As long, as I said, as long as it has the macroscopic causation, it's fully consistent with the microscopic story.
I see. Yeah.
Okay. Downward causation, they don't say. They say no. They say the effect on the microscopic constituents is incompatible with the causation at the microscopic level.
I see the difference. Okay.
That's a difference.
Haim?
Yeah.
Hi, this is Joel again. If, you know, scientists take, call it a small but still macro state compared to its constituents, for example, a molecule versus all the atoms or an electron, and they take that and they put it in a state of superimposed position. They have essentially create a wave function and can even do like a double slit experiment, which I think has been done with big molecules. So you have a normal molecule that was working according to nice causal Newtonian physics. You put it into a kind of quantum state, and then it goes back, and that's a holistic state because it's one wave function for the whole molecule, and it acts accordingly, and then it goes back, you know, back into its causal thing. The wave function collapses. Why is that not a holistic type of causality?
Okay. So indeed, there are your example, but there are other examples which are well known. For instance, superfluidity, those of you that know what it is, superconductivity, many of you know. These are all coherent, quantum coherent state on the macroscopic level. So despite what we said about decoherence and so on, normally we have decoherence when you go to macroscopic level, but you are right that one can have situations where there is a quantum coherence of the wave function at the macroscopic level, either molecules or systems at low temperatures and so on, like superconductivity and superfluidity. And there are other quantum states which are coherent at the macroscopic level. However, if you, I don't know if you remember the way we write down, these are coming out of Schrödinger equations, let's say. Schrödinger equations is equation of, in this case, in all these cases, will be, you know, there will be kinetic part, some of the motion of the particles, and then will be potential of the system. And the potential will be kind of many-body potential, but it will be some of the pairwise interactions between the atoms in your case, or the molecules, or in the gas or in the superconductor, between electrons in the superconductors and so on. It will, the fundamental law will be a sum of local interactions. It is true, again, that this sum of local interactions can give rise to holistic properties. But these holistic properties, like quantum coherence at the macroscopic level, arise from fundamental interactions which are local. And as we spoke about causality and special relativity and so on, the locality is very, very fundamental. The fact that interactions fundamentally are local and it takes time to propagate, and they're invariant. The same interaction between the atoms in the molecule the same interactions will be if you take those atoms and put them separately from the molecule. They will not show a macroscopic quantum coherence, but the fundamental interactions will be the same. So I think you have to distinguish between phenomena that appear only on the macroscopic level or on the semi-macroscopic level, like you suggest, and the ability, at least, to explain them as originating from more fundamental forces which are completely local. Okay, so when you have a coherent wave function, it does not mean that the nature of interactions between the atoms in the molecule are different. It's not. If the properties are different, that's fine. But the interactions fundamentally are the same as for individual pairs of atoms, not in the geometry or context of a molecule. Okay? I'm not against emergence. I'm not against new physics appearing at the macro level, whatever scale, whether it is molecular, big molecules, or really macroscopic systems. But all I'm insisting is that all phenomena in physics that we are aware of are all reducible. You can always explain them in terms of the sum total of interactions between local interactions between pairs or small groups of microscopic constituents, and those interactions are invariant. There will be the same interactions if you take it out of the molecule and put them on a dish. Okay, so if somebody says, well, you know, in the brain there is holistic and therefore ions behave differently, then the ions behave differently should be the same also in terms causally, then it should be the same if I put them in a dish. And we know that it's not. When we measure electrical properties of membranes in the brain, we know that they are the same properties that we'll see in the membrane conductance and whatever capacitance, all electrical properties in the dish. They're the same. That's what we do when you do cellular and molecular neuroscience. Okay, so of course, perception is not a property of an ion, and that's an emergent property. And I'm not going to say vision is because neurons have vision or ions have vision. Of course, it's a macroscopic phenomena, but we can explain it in terms of the emergent properties of coming out of fundamental microscopic laws, which are local and invariant. Okay?
Okay, thank you.
Can I ask a question?
Yes.
Something I don't completely understand. Can the observer effect in the microscopic state, can it be explained by a downwards causation or something? Be interpreted in such way, maybe?
You mean the role of observer?
Yeah.
That's a very important point, and there is a lot of discussion about that also in philosophy of science and some science also. And that's partly the reason why I had the trouble to go through quantum mechanics with you. Because under the fuzziness of interpretation of quantum mechanics, a very popular school says, you know, the observer has a role. There is not such a thing like a physical reality, because it depends on the observer, observer dependent. And that, I agree with you, opens the door to all kinds of weird things. What happens in the brain of the observer? And then entire physics is slave to a holistic element, which is the observer. And similarly, but less exotically, with the measurement theory that says the microscopic reality somehow depends on some macroscopic measurement, which is kind of mysteriously different element. This is precisely the reason why I wanted to clean these elements from our physical understanding. To the best of my understanding of physics and quantum physics, it's not observer dependent, and it's not even macro measurement dependent. There is a microscopic quantum physics, and which are independent of those in principle. Of course, if you have an observer is not careful, he may affect the system and so on. So once we take this in outside our ontology of physics, and I believe this is what I did, I tried to do in consistent quantum theory to get rid of those elements, then there are practical elements. Whether an observer of indeed, practically speaking, in a quantum system, observer very often is affecting the system, because by observation, you have to send photons. The photons are interacting with the electrical or magnetic fields or whatever. Then there are practical issues, and those practical issues, we can safely ignore them when we go to the macroscopic level. In other words, when we talk about things like brains, the observer, if it's not a metaphysical role of observer, like some people think, quantum mechanics is all about the observer. If it's not, then it is also pretty, it's a practical issue. If you are not careful in doing experiment, then often the observer messes up the experiment, and the results are contaminated. But you have to do careful experiments and careful observations and to neutralize this. So I don't think that this gives room to some fundamentally new concept like observer, in my view. But I agree with you that in order to argue for this, I had to conceptually make quantum mechanics clean, objective physics, which is not observer dependent. Okay? There is another notion of observer, which I'll come, if I have time, probably not today. I'll come back to that. It's more philosophical. It's not about downward causation, and I have less an opinion about it. But we'll come back to it maybe at the end. Okay, let me at least begin. If there are more questions about that part. Okay, what I want to start at least today is another chapter in this, which is the mental physical relations. And all that I said so far, you could think about macro versus micro, not necessarily mental versus physical, but there is something special about mental to physical, which I want to address, okay? And there are three main ingredients to the discussion of the mind-body or mental-physical problem. One of them is mental causation. Another are really mental states emergent from the brain, like John Searle claims. And the third one is consciousness. Okay, so the first one, I don't want to repeat myself. The first one, mental causation, is just another example of emergent causation or downward causation. I already said something about it. And I summarize here that you cannot, at the same time, if you adopt the microphysical causal closure and the causal exclusion and the mental causality, and at the same time, you want to say that the mental properties are somehow independent causal, these are not consistent with each other. So I believe that mental causations are there, but they are mental relations, causal relations are there, but they're reducible to microphysical laws. So that's an example of what I discussed already. I don't want you just to repeat it. But what about emergence? So I said in physics or in sciences, physical sciences, I am strong believer in the notion of emergence. Can we say that the mind is emergent phenomena of the brain? Now, why not? Okay, so here's, at least I'll introduce the problem. Here are examples of systems that I believe that are not emergent from physics and are not even, because they're not reducible. Emergence and reduction comes together. If the system macro is not, if system A is not reduced to system B, it cannot emerge from system B, okay? Mathematics. What about mathematics? Is mathematics reducible to physics, or does it emerge from physics? What do you think? I don't know. Can anybody suggest an opinion? I spoke a lot about reduction. Okay, what about mathematics? It's part of science. We spoke about physics, micro and macro, physics and chemistry, chemistry and biology, neuroscience. What about mathematics? It's science. It is the heart of science. How can you have physics without mathematics? No. So is mathematics reduced to physics? Jenny, what do you think? I don't know. I don't know if she's listening.
Yes.
What do you think? I don't know. When I gave this lecture again, one of the first times, I said mathematics is not reducible to physics or to physical sciences. I was attacked physically by some distinguished neuroscientist actually in the audience. How can it be? So here's what I'm saying. Suppose we are examining a mathematical theorem. So on one hand side, if I'm looking at the brain of a mathematician that proves a theorem in mathematics, I believe that I can reduce the mental process of proving that theorem to physics, to neural processes, molecular biology, biophysics, and physics. But if you ask me about the theorem itself, the content of the theorem, is it reducible to physics? I would say no. It's kind of subtle. Do you agree with me, Chavre?
I agree. I think that
Okay.
not even mathematics, if you just think about the notion of number, I don't know.
Yeah, okay, so I list here things like language, symbolic systems,
But
law.
what about, so if you follow the neural processes of this mathematician, when he thinks about this theorem, comes up with the theorem, so isn't it reducible to this neural process?
It is. The discovery of the theorem is reducible to neural processes. It's subtle, I agree with you. And that may be related to, I wanted to defer it to later on, but related to Elisheva's question. And the point is the following. If I follow the neural processes of the mathematician while he proves a theorem, these neural processes, these neural processes will be reduced to physics, to everything, like every other thing. However, it's more subtle because I don't think I'll be able, by observing the neural processes, to interpret it in terms of mathematical theorem. That will be hard.
Isn't all this, can't you reduce all these notions to some fundamental logical
Okay, so is logic reduced? Is logic reduced to physics?
So maybe when you go to the very basic notions of logic, it has its roots in the physical world, like adding things or maybe
That's a
choosing
question.
things.
Also, maybe
logic did not exist. If the world wouldn't exist, the logic would not exist. Mathematics will not exist. Pi will not exist if there was no world, no universe. I don't know. That's a good question. I believe that there is a distinction between the content, the abstract content of something, and its physical instantiation. So mathematics has internal structure. It's not only logic. You're saying logic, but it's more than logic. But let's not argue about that. There is some internal structure, symbolic structure, logic, and other rules of how you prove theorems and so on, which have their own rules. These rules, I don't think I can explain why these are the rules in mathematics based on physical laws. It's not reducible in my view. Any symbolic system is not reducible. The same as language. Language, the emergence of language, the evolution of language, the brain processes of language is all reducible. But the language, the rules of language itself, I can explain, why they came to these rules and why in other rules, but the rules itself, if I'm looking at the text and I'm asking, is this grammatically correct or not? This is rules of language. It's linguistic rules. It's symbolic rules. So,
Haim, can I?
So if you have the mathematician proves two different things. Let's say he gives two proofs. You say there's a possibility that those two proofs has the same. Physically, we'll see the same thing, basically. I mean, there will be no difference in the real world regarding those two different proofs.
Yeah, philosophers argue about that. I don't want to philosophize too much about it. Yes, the philosophers and ask about this also, not only about mathematicians, but also, two systems compute a sequence. Is it the same computation or not? Who gives the content? Basically, who gives the content? So I think that it would be very hard to take the neural processes only, and from that to say, well, what is the outcome of this neural process is this theorem. I think this will be very hard. However,
going down up, that might always be hard to come from the neural processes up. The question, if you have two different processes on the high level, could you say that they have the same low level?
The same low level? What do you mean? The high level is neural, or the high level is?
No, the high level is the mathematical proof, and the neural.
But also I wonder.
Also, perhaps, I don't know, maybe.
I wonder if what needs to be reduced here is the mathematical theory or the cognitive states that enable us to formulate that theory.
No, so the cognitive states, in my view, okay, this is the question here about cognitive states. Okay, so we'll come to cognitive states. The neural states, I think, are reducible. So what I'm posing, at least the question, at least we can understand. So on one hand side, neural or any biological system, I believe, are reducible, and we explain what does it mean reducible, and what are the causal relations, all the things that we discussed so far. That's one end. The other extreme is symbolic systems, the content of which I don't think they are reducible. You cannot reduce them from physics. Although physics is based on mathematics or physical, not physics, not the physical world, but physical theories and models are based on mathematics. They use mathematics. But the interaction between elements in physics, gravity, and so on, all these interactions are not able to explain a mathematical theorem. I think this is a different thing. These are abstract conceptual systems. Their content and the rules of derivation and so on are not reducible. So I'm putting them into two ends of the spectrum. Reducible, not reducible, in my view. Now, cognitive systems, this is the question. Do they belong to the neural, physical, biological, and so on, or do they belong to these symbolic, abstract things which are not reducible? This is basically the question which I want to raise. Okay? And again, once I took out causality, downward causation out of the game, I am relaxed now. You can argue. I don't know. This is kind of philosophical question. I was going, and I won't be able to do it today, to describe some of the thoughts and the problems that are in the literature of philosophy of mind and cognitive neuroscience. But I think this is the way I want to phrase the problem. Cognitive is in between. How do we conceptualize the relation between cognitive systems and the neural and physical systems? Are they more like mathematics, or they're more like biology and physics? Yes. Somebody asked.
What do you think about the option that you can't reduce mathematics to physics, but you can reduce physics and language and symbolic systems to mathematics?
Wow.
Sorry.
I don't know even what it means. Reduction, yeah, I wouldn't even know what it means to begin with. What would it mean? So the only thing that maybe it would mean, what you said, is that one would be able to derive from purely mathematical considerations the properties of our world. I doubt very much. And
I think in many cases you have solutions that are not physical, even though they're completely true mathematically. So I guess it's not true.
Yeah, but okay, so you cannot understand physics. You cannot have physical laws. You cannot interpret. You cannot build the science of physics without mathematics. I'm not suggesting that throw away mathematics, but that's not the same as saying that physics is reduced to mathematics or that mathematics is reduced to physics. I think mathematics as an abstract concept may exist even without physics, without the world. In principle, I mean, it's an abstract relation. It's not, in my view, I don't see how it all, it's really a different nature, how it all I will derive a mathematical proof from physics. Maybe from logic, as Jonathan suggested, but how will that derive logic from physics? I can imagine that without logic, it will be hard to build a mathematical theory of physics without logic, but the other way around. It's more fundamental. You can say logic is something, it's more fundamental than any, physical theorem. So anyway.
What is the fundamental difference between mathematics and emotions, or why do you say that fear
motion
is
or emotion?
Emotions,
motion?
like fear, anxiety, and fear is also kind of abstract thing, but all the cognitive
that's the discussion that I won't have time to do now, and I'm raising the question. Precisely this, I'm raising the question. Are mental states like fear, pain, and so on, emotions, examples, beliefs, and other things, are they more like mathematics, abstract things, or more like physics? Okay. Because if we're doing cognitive neuroscience, then we kind of implicitly assume they are more like biology and chemistry and physics. If you go to mathematics department, you will not see wet labs studying mathematics, by doing experiments in physics, right? You don't see that. But you do see in psychology, and people measure something about the brain, and people look at neurons and do cognitive neuroscience. So what is going on here? That's the question. So let me end up today's lecture by posing this question. Okay.
Haim?
Yes.
There is a debate in mathematics whether mathematics is discovered or created.
Right.
And I totally agree with your position personally, but there are people who say it's discovered. To the extent it's discovered, you could argue that in fact it is emergent, or, macro emergent of neural process, and that's what we call discovery. To the extent that there are mathematicians who don't, for example, accept certain concepts like a pre-constructed idea of infinity, and they're constructivists, and they reject this idea of infinity and Cantorian mathematics and all that stuff.
I agree. Again, I don't want to make too strong statements because it's complicated and people. But I think it is a different. It's a different question. When I say mathematics cannot be reduced, in my view, to physical sciences, I did not take a stand or would not necessarily take a position about what mathematics really is. So what do I mean by that? You can, on one hand side, say, okay, mathematics, as you know, a Platonic view of mathematics. Mathematics or mathematical objects, okay, are abstract objects that have objective reality. You can be realistic about mathematics. Platonic view. Mathematical objects, so to be realistic about mathematics doesn't mean that mathematical objects are part of physics. It just means that as physical objects are real, that's part of the realism of the physical world, mathematical object is a space that you can say they exist. A circle exists, pi exists, square exists, Euclidean metric exists. They exist in absolute sense, and we discover those existence, okay, on one hand side. But they don't exist in the same of physics. You cannot do mechanism and causal and perturbation. It's not a physical existence, but it is an existence, Platonic sense of existence. The other view of mathematics is deflational. It says, no, there is no such a thing like existence. It's convention. Mathematics, people found it useful to indulge in all these systems and so on. So in that sense, if you look at my list in the slide, legal systems is an example. Nobody will say it's Platonic unless you are very, I don't know. Okay, most people say legal systems are convention. Human beings, society, it's all about social interactions and so on. And it's and you generate some conventions. So legal systems are not reduced. Then how people came to do this is reduced. But the rules itself, you cannot say, this is wrong in British legal system, but it's right in American legal systems, and go to the functional MRI and resolve this issue. No, you have to open the text, the law, books of law, and find out which one is right or wrong. So mathematics, you can argue it is realist. You can be realistic, and you can say we discover some truth about mathematics. Or you can say there is not such a thing like true in mathematics. Mathematics is convention. So I think it is a different debate. In both cases, it will not be reducible to physics. In both cases, mathematics is not reducible to physics. Okay, so I want to separate those debates.
But on the side of the debate,
discover mathematics means that there are mathematical truth, that we mathematicians discover those truths.
Oh, agree. I totally agree with that. But to the extent people think we create it and it's a convention and it's a convenient way to describe physical processes, wouldn't that be essentially reducible to physics at that point? It might not be pragmatic to do that, but that's really where it comes from. If it's created and not discovered.
It is where it comes from, like language. But what I'm saying, mathematics as an abstract set of rules the rules cannot be decided about by using physics. What made people think about those rules or create those rules is reducible, like a legal system. But if you go to a judge and judge says, well, this is, a lawyer says, you know, the rule is like this, and the judge says the rule is different, you misinterpret and so on. Evolutionary theory or sociology is not going to intervene, right? It doesn't going to have any say. So it's the content of mathematics and the content of legal systems is abstract. Yeah, and it has its own rules. And the rules are internal to that system. The rules are internal to the system. A neuron doesn't have its own rules. The rules of the neuron is basically physics and biology and so on and so forth.
Can I say something?
Yes.
Mathematics is different from the what you said, laws and stuff like that. It's the building block of physics. I think that's a problem. What Joel means. I think it's not like they're not equals or something. So that's a problem.
I agree. I can ask you even a more subtle question. The laws of physics, are they reduced to physics? I don't know. It's a hard question.
That's what
now
Josh Tenenbaum is doing, no? Trying to see how they're found in brains.
Yeah, I don't know. I think they are not, because they are kind of abstract. They're conceptual,
but
mathematical.
Maybe it's similar to kind of Chomsky, the view on language, that it's kind of built in brains, like math and maybe physical laws.
No, but it's different. Again, if you argue about language, about the origin of the physical origin of language, then Chomsky says it's engraved, it's hardwired, and genetics, whatever. And others say, no, it's adaptive and it's learned and so on. But both sides of the debate, Chomsky and anti-Chomsky, I think are still talking in terms of reduction to physical or biological processes, you know, evolution, genetics, structure of the brain, and so on. But I'm saying the rules of the language, the structure of the language itself, as an abstract symbolic system, are rules which are not decidable by looking at the physical processes that gave rise to it in most of the time. Maybe in some cases. You basically have to learn language. You have to learn the rules of the language. You learn about the evolution of the language is fine. You can argue this way, that way, but the rules of the language are not rules of physics, in my view. The same as the mathematics. So symbolic systems, I think they have their own internal rules, which is different from the question how they arose, how it came about that human beings know language or learn language or have language or know mathematics and so on and so forth. Or creates, human societies creates this structure or that structure of social norms and laws and so on. This is the distinction that I want to make. But again, I agree that it's complicated. It's complex to do this separation. But that's the way to me, it's kind of appealing. Anyway, think about it, and we will discuss more about what does it mean for cognitive states and processes. Are they more like mathematics and so on, or they are more like biology and physics? All right. Okay. Next week we'll continue. Okay. Toda raba.
Yeah.
Yeah.